All right, so let's talk about how to write programs in ACL2 because we need to have programs that we can test, okay? So what I'm going to do is I'm going to go to the same place where we were. I'm going to hit the double up arrows to kind of cancel everything and start from scratch, okay? So first thing I want to say is programs in ACL2 always look like functions, okay? ACL2 is a functional programming language. And what that means is that programs really are functions. So you're going to be writing function definitions, and you're going to be using functions. Now, we already met a lot of the functions that we're going to need, like plus and minus and times. Those were functions. Plus takes two arguments and returns the sum of the two arguments, for example. We also saw and or and not and implies. Those are also functions. And takes two, actually it could take two or more arguments, and it returns true when all of those are true, nil or false when at least one of those is not true. Okay. Here are some others that are useful. Like for example, there is a function called POSP, P-O-S-P, and that stands for positive integer. So this returns true when you give it a positive integer. So for example, POSP of 1, that should be true, and POSP of let's say 1/2 should be false, which is nil, right? And POSP of, say, the string Fred is also false because that's not even a number, okay? So that's one function that you should know. What about others? Well, let's see. Here's a function that you may not think of as a function, and that is if, okay? So what if does is it lets you take three arguments, if condition, then part, else part. Okay, that's what it looks like, and it will evaluate the condition, and if the condition is true, then it returns whatever the then part is. If it's false, then it returns whatever the else part is. So let's have a concrete example, okay? So let's try if t, then 5, else 4, right? So if we evaluate this, since t is true, this will actually return 5 because that's the then part. If t is false, then it will return 4, okay? Now, notice that this is actually just a function of three arguments. So if I write it like this, oops, like this, that's more obvious. If t space 5 space 4, okay? Now, let's look at some others. For example, if, here's another function, less than 3, 5, okay? So what does that mean? That means that 3 is less than 5. If that's true, then we will return 2. Otherwise, we want to return 1. Okay, there's a function. Okay, some others things that we can have. If greater than 3, 5, then return 2. Otherwise, return 1. That should return 1. Okay, let's put in there the return values. It should return 2. This should, of course, return 5. Okay. Now, some other things that we can do. Let's take, for example, and of t or t nil. Remember, we did this before, and this will actually return true, or t, okay? Now, let's try this, and p or pq. What should that return? Well, here's a problem. We don't know what p is. We don't know what q is, right? So we can't actually say that that's true, okay? This is actually an error, and it's an error because we don't know the values of p and q, okay? But how about this? Or p, not p. What is that? Well, I think you can look at it and say, well, that's going to be true no matter what p is, but actually it is an error because c is a variable, right? So we don't know what it is, so we actually can't evaluate it. We will get an error. However, this is actually a little preview. This is a theorem prover, okay? So we can actually say, by the way, is it the case that this is a theorem? And what this will do is it will return true, okay? Because it is in fact the case that p or not p is a theorem. Let me just go ahead and evaluate all these expressions, okay? And you notice that it stopped right here. That's because this one is an error. So it says I was not able to do that, okay? Let's try. I can't do the next one, right? Because that one true is an error. Let's continue. There you go. All of them are now done, okay? And you can see that right here. It says proof succeeded. I was able to prove that p or not p.